we're looking at circumference and arc length in circles. So whenever we have a circumference of a circle, our equation is always we take the pi times the diameter, or you can take the radius, multiply it by 2 to get the diameter, and then times it by pi. So you can either use pi times diameter or 2 times pi times r. So I usually just go with that first one and just say pi times diameter and just figure it out. So the circumference of circle 1 is equal to pi times my diameter, which is 7. We can just simplify pi times 7 to be 7 pi. This would be leaving our answer in terms of pi, meaning an exact answer versus a decimal approximation. Number 2, I have the radius. Now, circumference is pi times our diameter. If I want to find the diameter, I have to take that radius and multiply it by 2, because both of these are 2.1 feet, which would give me 4.2. So pi times 4.2, we usually just write this as 4.2 pi. Okay, let's talk about arcs. The measure of an arc is in degrees. An arc length is a fraction of the circumference. So it's a linear measurement. When I find a circumference, it's like if I had a can and I took a string and wrapped it around and then I measured the length of that string, that would be the circumference. A length of an arc is a piece of the circumference. So the arc shown in two circles, they're called concentric circles, they have the same radius. They're going to both have the same degree measure, the same central angle, and the same arc measure, but they do not have the same length. This S2 is larger than S1. So just because they have the same angle doesn't mean it's the same length, because we could have a bigger or smaller circle. Because the arc length is a fractional part of the circumference, it can only be found by multiplying that fraction by the circumference of the circle. If I want to find the length of an arc, what I have to do is I'm going to find the circumference of the whole circle, but then I don't have the whole circle, I only have this piece. So I'm going to take my angle and divide it by the total degrees of 360. That will give me the fraction of the circle for this arc length. Now I'm wanting to find this bolded arc here. I need to know how many degrees are here. Don't let the 60 degrees fool you. The 60 degrees is not the part that we're looking for. We're looking for this piece. So if I take 180 degrees and minus off 60, I have 120 degrees for the piece of the circumference that I'm looking for. Now, if I'm trying to find the whole circumference, circumference is equal to pi times our diameter. Our diameter is 12. So our circumference of our whole circle would be 12 pi. But I am not looking for the entire circumference. I want the length of just a piece of the circumference. I want 120 degrees out of 360 degrees. So I'm going to put 120 over 360 times by 12 pi in our calculator. Now I will need to make sure I have an x in between, or else the calculator is not going to know what to do with that. Okay, this will give me 4 pi for that bolded arc there. That's the length of that arc. Now if I want to find this piece here, I need to know first the circumference of the whole circle. Now a radius is 3 centimeters, so the diameter would be double that. 3 plus 3 would be 6 centimeters times pi. Pi times the diameter would be our entire circumference, but I don't want the entire circumference. I want a piece of the circumference. I have 35 degrees for this angle, and this other angle, these are vertical angles, so they are going to have the same central angle. So this is also 35 degrees. So we have 35 degrees out of 360 degrees for the whole circle. It's a fraction of the circle. So 35 out of 360, and then multiply that by 6 pi in your calculator, and you should get 7/12 pi. Now, this, leave your answer as a fraction in terms of pi. This is an exact answer. It would be in centimeters. But we are also going to find a decimal, so an approximation. So this, if I put this in my calculator, I get 1.83 centimeters long, where on number 3, if I do 4 pi, and change that to a decimal, I will get 12.57 feet long. So it, depending on how they ask it, if they say to round it, then do a decimal. And otherwise, you want to keep it as exact as possible, and so you would put 4 pi. Number 5, I have 5 units for my radius. My diameter is going to be double that. 5 plus 5 is 10 centimeters times pi. So the entire circumference is 10 pi, sorry, not centimeters, inches. And then I'm going to multiply that by the fraction of the circle. I have 37 degrees out of 360 degrees. So in our calculator, 37 out of 360, and then we're going to multiply that by 10 pi, and we get 37/36 pi inches. Now that's the exact answer. If I want a decimal approximation, this would be 3.2, rounded up to 3 inches. So it would be a linear length. It's the length from here to here. Number 6, to find the circumference of the whole circle, I'm going to have 10 is the radius. I double that to be 20 for the whole diameter. 20 pi times diameter would be 20 pi, but I don't have the whole circumference. I just have the arc length is a piece of the circumference. So I'm wanting from here to here. Be careful. We are not using the 70 degrees because that's the part that I don't want. I want everything but the 70 degrees. So I'm going to take 360 degrees minus off 70 degrees, and I get 290 degrees for the rest of the circle that I am looking for. So I'm going to take that 20 pi and multiply it by 290 degrees out of the 360 degrees for the circle. That gives me 145/9 pi. That would be the exact answer. If I want a decimal approximation, I'm going to have 50.6 centimeters. That's how long approximately it would be if I took like a tape measure and wrapped it around, or a string and measured it for that piece of the circumference. On number 7, we're going to find the circumference of circle C. Now, I don't have the whole circumference. I know the arc length though. To find the arc length, this is going to be equal to our angle out of 360 degrees multiplied by the circumference of the circle. So I know the arc length right here is 7.5 meters. This is equal to my angle out of 360. So my angle is 76 degrees out of 360. And then I would multiply that by my circumference. Okay, now there's a trick whenever we're multiplying by a fraction. I am going to multiply by the reciprocal. So if I had 1/2 x equals 7. If I multiply both sides by 2 over 1, the 2's would cancel and the 1's would cancel, and then x would equal 7 times 2, which is 14. So I'm going to do that by same thing, same idea, by multiplying by the reciprocal. So what I'm going to do is I'm going to times both sides by 360 degrees over 76. The 76's cancel, the 360's cancel, and so I get my circumference is equal to 360 divided by 76 times by 7.5. And then I get 675 over 19 would be the circumference of that circle. It's approximately 35.5 meters long. Okay, now we're going to find the radius of the circle R. Now my arc length equals our angle out of 360, and then we're going to multiply that by our circumference. But I'm not trying to find my circumference, I'm trying to find my radius. Our circumference is equal to pi times my diameter, but the diameter is equal to 2 times the radius. And since I'm looking for the radius, 2 pi r, I will just multiply that by 2 pi r so I can find out what the radius is. Okay, let's substitute what we have. The arc length is 10.5 feet. Our angle is 150 degrees out of 360. And then I'm going to multiply that by 2 pi r. Now again, just like the last question, to get rid of that fraction, I'm going to multiply by the reciprocal on both sides. 360 over 150. And the 360's will cancel. The 150's will cancel, and I'll have 2 pi r. Make sure you put a times in there. I get 126 over 5. Now to get r alone, I'm going to divide both sides by 2 pi. So I'm going to take my answer and just divide it by 2 pi. Find the pi button on your calculator. And our radius is approximately 4.01. It would be feet there. Now, sometimes you're not given a picture. So I want to just draw myself a circle, put in circle P. I have some length Q, R is 2 pi inches. And this measure of the angle is 120. So the length is 2 pi, the measure is 120 degrees. So what is the radius of the circle? We're going to do just what we did on the last question. We're going to take our arc length is equal to theta over 360 times by 2 pi r. Our arc length is 2 pi. Our angle is 120. And we times that by 2 pi r. Now I'm going to get rid of my fraction by multiplying it by 360 over 120. That gives me 6 pi equals 2 pi r. If I divide both sides by 2 and pi, the pi's cancel. 6 divided by 2 is 3. So my radius equals 3. And our units is inches. So 3 inches is the length of that radius. Okay, last one. We're finding the angle. So we know our arc length equals our angle out of 360 times by the circumference. So my arc length is 4 pi. My angle, we don't know. So I'm going to keep theta over 360. But I do know my circumference. My radius is 10. My diameter would be 20 because I'm going to times that 10 by 2. And circumference is equal to pi times my diameter, which is 20. So 20 pi would be my circumference. Now I'm trying to get theta all alone. So let's go ahead and divide both sides by 20 pi. The pi's cancel. 4 over 20 is 1/5. I could do this a few ways. I'm just going to multiply. I want to get theta alone. It's being divided by 360. I'm going to multiply both sides by 360. And 360 divided by 5 is 72 for theta. So theta would be 72 degrees.